Alright, so in this final video for this section on recursion, I want to go ahead and take a look at one final problem involving recursive methods, which is going to be Sierpinski's carpet. So for this particular example, we're going to be looking at something that's a bit more complex, a little bit more sophisticated. One particular difference between this problem and the ones that we've seen so far is that this is actually going to now incorporate some amount of graphics in it. So we're going to be looking at a recursive method that is used to actually draw out a particular picture. So before I get into the code for this, I want to take a moment to just run this with a couple of different parameters that I specify, just so we can see exactly what this is drawing or what Sierpinski's carpet actually even looks like. That way then when I start to explain the code, we can better understand the individual pieces that go into actually creating this, this picture. So I'm going to come over to my terminal. I'm going to go ahead and compile my program. So it's going to be carpet.java. Then we'll go ahead and run this. And for this particular implementation, I've set it up to allow me to choose the number or the levels of recursion that I'm going to apply to it. So by applying different levels of recursion, the way that the picture is drawn is going to look slightly different. So to start off with, I'm going to do 0. So this is going to call my method that's used to draw out a certain portion of this picture one time. So that's going to occur in the start method. So think of it equivalent to that first call in the main method for all of the other programs. But it's not going to do any recursive calls to it. So at no point in this particular example is this method going to call itself. So if I go ahead and do this, we can see that what it's going to do is it's going to draw out a single black square, and then the single call that I'm making is what's going to add this white square in the middle of it. So what's happening is it's picking out the center of the larger square, and it's drawing in a white square right there. And if I do this recursively, what it's going to then do is start looking at the 8 other squares that surround this white square. So you can take a look and see if we divide this into thirds, we have one black square in this upper left corner, we have another black square just above it, another black square in this upper right corner, 2 more black squares on each side of it, and then 3 more along the bottom in kind of that same pattern as the top. So you got your lower left corner, your bottom, and your lower right corner. And so then within each of these black squares, when we do this recursively, so we do this with one level of recursion, we'll go ahead and draw in a white square in the center of each of these. So I'll go ahead and close this, come over here and we'll run this again, and we'll do this with one level of recursion. We'll do it that way. And so now we can see a single white square being drawn into each of those at their center. And so now they've got, another 8 smaller black squares surrounding them. If you try to picture this being divided into thirds, so you've got one black square here, another black square here, another black square there, so forth and so on. So if I add yet another level of recursion to this, then it would go ahead and draw a white square into the center of each of those black squares. And it would repeatedly do this depending on the number of levels of recursion that I'm applying. So the thing that we have to consider is that if I'm going to try to draw this many squares on just one level of recursion, so when we start with 0, it just drew a single white square, but when I applied just one level of recursion here, it's going to draw 8 more of these. And then of course if I do this again, say I do 2 levels of recursion, well now it's got to draw 8 of those squares around each one of these 8 squares. So now it's going to add another 64 squares to this. So thinking about that, we need to keep in mind that as I add more levels of recursion to this, the number of methods or the number of times that I need to call my draw method for this, that's going to increase at an exponential rate. So I want you to keep that in mind. I'm going to try to apply several levels of recursion to this as we go, and I want you to keep in mind how slow this program runs very quickly. So even with just a very small number of recursion being applied. But before I get into all of that, so before I run this a couple more times, I want to go ahead and take a look at the code for this now. So for this particular program, I've gone ahead and used JavaFX as my way of going about drawing out the scene for this. So that square that we're going to draw and all the additional white squares that we draw inside of it, that's going to be applied to a particular element or a particular container from the JavaFX library. So looking at the imports, we've gone ahead and brought in the pretty typical, pretty standard imports for a JavaFX application. We've got our application stage and scene class. So we're going to go ahead and extend the application class so that we can use various methods that are necessary for JavaFX. We've set up our stage and scene, since these are also essential to being able to actually create the application window. Getting into these next couple of imports, these are going to be things that are actually unique to this particular program or this particular application. So the first one's going to be the pane layout container. So you can think of the pane as being sort of like a canvas-like element. This is going to be what I end up drawing all of my shapes, those squares, onto. And it's also how I can go about applying some color to those shapes. So then taking that into consideration, these next two imports, one of these is going to be the rectangle class that comes from the shape package. This is how I can actually go about drawing those squares. Since a square is nothing more than a rectangle, but all four of the sides are going to be equal, so we'll need that class to do that. And then the other thing is going to be the color class that comes from the paint package. This is how I can go about actually adding that black color for the fill color of my rectangles. So then getting into the body of my class, we can skip over the main method. All we're going to do there is just call the launch method. Going into the start method, we'll take a look at this. I'll kind of work through this, and then we'll take a look at one other method I've added, which is this draw gasket method. So inside of the start method, the first thing I'm going to go ahead and do is just ask the user to specify the number of levels of recursion. So I've got one additional import right here for the scanner class. So I can go ahead and read the user's input and then go ahead and get that using the next int method of the scanner class. We're going to go ahead and assign that value that the user inputs to a variable called level. Next, we're going to go ahead and create our object of the pane class. So I'm just going to call it pane with a lowercase p. So we'll end up using this object to essentially add all of our shapes to. So we'll draw out all of our squares onto that. In the next line, so line 25 here, I'm going to go ahead and create an object of the rectangle class. I'm going to call it box. And then for the parameters of my rectangle, I need to pass in 4 values. So these 4 values that I'm passing in, the first 2 are going to be an XY pair for a particular point somewhere in my pane where I want to draw this. So basically it's just determining where I want to start off, like the starting location for my rectangle. So if we think about this for a moment, I'll go ahead and run the application once with a level of recursion of 0, just so we can take a look at this. So that 50-50 that we're using is going to be this upper left-hand corner. So the first 2 parameters just specify the upper left-hand corner of where I'm going to draw my square from. And then if we take a look at the other 2 parameters, we have 699 by 699. These are going to serve as essentially the width and the height of the rectangle that I'm trying to draw. So in this case, because these are both equal to each other, then it's going to end up drawing a square. So if you look over here, that 699 is going to be going along this way, and then the second 699 is going to be going along this way. So it's going to be for the length and height of our square. Next, we're going to go ahead and use the setFill method on our box object, and we're going to go ahead and set its color to black. So that's how we get this black color for it right here. On this next line right here, we're going to go ahead and take our pane object and we're going to add to it this rectangle. So you can basically think of this as a way of being able to actually take our rectangle, so that box that we created, and actually draw that onto our pane. So drawing it onto our canvas-like element. In the next line right here, we're going to go ahead and call the draw gasket method. So this draw gasket method is what I'm going to be using to create my white squares that I put on top of that black square. So the very first time that I call this is going to be from within the start method. So this is essentially this is going to be my non-recursive call to draw gasket. The things I'm going to be passing in, we're going to pass in the level, so whatever level we are currently on with recursion, the pane object so that we know what it is that we need to draw this white square onto, and then a couple of dimensions, and I'll get into these individual dimensions once I start talking about the draw gasket method in a moment. To finish up on the start method, we've also got to create the scene, so we're going to set up our scene object. The pane is going to be the root node of it, and then for the dimensions we're going to do 800 by 800. So if we look at our application window, we'll see that there's a little bit of extra space surrounding it, letting us know that the window's dimensions by default are a little bit larger than the pane that we are putting these shapes inside of. We'll then go ahead and set the scene for our stage, and then also display our stage, so make sure that it's actually visible to the user. Okay, so we've got our first call to draw the gasket on line 30, so that's going to be inside of the start method. So now coming into the actual definition or the body for our draw gasket, first we'll take a look at the method header for this. So this is going to be a void method, doesn't return anything, we're just using it to draw a shape. Going through each one of the parameters, so I mentioned before the first two, this one's going to be the level, so this lets us know which level of recursion we're currently at, and also helps us to keep track of how many levels of recursion we're going to apply. So that's how I can determine things like the 0 to end up with this shape that we have here, or a 1 to go ahead and draw a few additional white squares surrounding this slightly larger white square. Next thing is going to be our pane. So as I mentioned, this is just to keep track of where or what it is that we need to draw our white squares onto. The next two values are going to be an x and a y. So these two integers here, essentially we're using these to keep track of where the upper left-hand corner for this particular square needs to be. So it's kind of like having to specify our parameters for this method right here. So we have this 50-50 as an xy. Well, whenever I draw any of my other squares that are going to go inside of that black square, I need to go ahead and use the constructor for the rectangle class. So I've got to keep track of the same sorts of parameters or those same sorts of dimensions. So in this particular case, the x and y here, if we think about it with 0 as our level of recursion, we're going to draw just one square. So we need to know where its upper left-hand corner is right here. And then the other thing we're going to need, this last dimension, is going to be its side. So for the very first one, we went ahead and just drew out the black square. We passed in the 700 right here. So this 700 that we initially pass in, this is going to correspond to essentially the dimensions of our black square. So you'll notice that for the black square I did 699 by 699, but the value that I'm passing in is going to be 700. The main reason that I'm doing this is because once you see in a moment when we do a slightly higher level of recursion, eventually these squares become very, very small. So this is kind of just to offset a slight rounding error so that we can at the very least draw out essentially squares that are about a pixel in size. And that's pretty much the only reason why there's this discrepancy between these two. Okay. So we're going to go ahead and pass in 700 for the side, and then right here in the very first line of our draw gasket, we're going to take that 700, so that side that we passed in, and we're going to divide that by 3. And the reason that we're going to divide that by 3, if we take a look over here, in order to get this side, we have to remember that we're going to split this into thirds. So we imagine this entire length right here was our 700 that we passed in. Well, in order to get to this one, we're just going to go ahead and split it down and just use 1/3 of whatever that value happened to be. And so then that 1/3 that we get, we're going to go ahead and store that into a different variable that we call sub, and then we're going to start using the sub in a couple of different cases here to be able to keep track of the dimensions of our square. Then the next couple of things we're going to need for our constructor for our new white rectangle, or our new white box that we're going to put inside of our black box. The first one's going to be the position. We're passing in this x and y, so that's going to be the 50 by 50, matches up with the starting point for that. But right here what we're going to go ahead and do is add the sub to it. So to explain briefly what it's doing here, so initially we have the x and y right here, 50-50, and then if we go ahead and add sub, which is the length of one of the sides of the smaller square, if we move over by the length of the sub and then by the height for sub, we see that we end up at the position of the upper left-hand corner for where we're going to draw our white square. So that's the reason why I need to go ahead and do it in that way. Additionally, when we go ahead and draw out the length and height, so when we specify those two, we're going to take whatever the sub is and we're going to subtract 1 from it. So this kind of matches up with what you see here. I took whatever sub was originally, so 700 for the side, and to draw my big black rectangle, I subtracted 1 from it. So I did 699 by 699. So we're going to do something kind of similar here. Again, the purpose of this is to try to offset that rounding error when we get to very, very tiny white boxes. We'll then go ahead and set the fill color to white. So we're going to go ahead and draw a white square here. And then we're going to go ahead and do the same thing that we did up here so that we can go ahead and add that white box to our pane element. And then right here, this is where we're going to actually start checking to see whether or not we need to perform any kind of recursion. So we're going to check to see if our level is greater than 0. As long as it's greater than 0, we're going to go ahead and step through this set of additional recursive calls. At the very beginning, we're also going to make sure that we decrement the value of level. So again, this is where we see that line where we have to decrement or increment some particular value that we're working with. In this case, level, this variable is going to be used to keep track of how long we're going to be doing this recursion for. So then if we get into each one of the 8 methods for this, so the very first one, we're going to do draw gasket, and we're going to specify for all of these, the level and the p. We're just passing in whatever this decremented value for level is. So if we start off with, say, 1 at the very beginning, when we do this, we're going to pass in 0 for all of these. So for every one of these calls, all 8 of these, when we step through them, level is going to be 0, so they're not going to have any additional recursive calls. This is only going to happen once. The p is always going to be constant since we're always drawing this to the same pane for everything, so we don't really need to worry too much about that. For our x and y positions, we need to be able to specify where this will initially need to start. So essentially this x and y is going to be the upper left-hand corner of the larger black square that we need to draw each of these white squares into. So if we consider this, go ahead and close this, and we'll run this with one level of recursion so I can describe this now. So taking a look at this, for the very first one that we're looking at right here, we need to pass in an x and a y. So we're going to give it the same x and y that we originally had. The reason for that is because of the fact that for this upper left-hand corner, this is going to be the first square that we're going to take a look at. We'll see that the upper left-hand corner of it is still going to be the exact same upper left-hand corner for the entire black square that we had originally. So that's going to go ahead and just be exactly the same as it was before. So we're just going to pass in the x and y that we originally used up here, or say like right here for our original arguments. We're also going to go ahead and pass in the value of sub. So now this sub, the side divided by 3, that's going to become our new side when we do our first recursive call to this. So that's going to be, instead of being this for our side, now we're going to be using just this much here for our side. And so then when we divide that by 3 to draw this square, we can see that we get down to just this slightly smaller lengthwise side for our smaller white squares. So that's going to be for the upper left-hand corner. The next one's going to be for the one that's just above our white square. For this one, the main thing that's going to change is that I need to shift over the x position by the length of sub. So now I need to move it over by this much. And so now the upper left-hand corner is going to be about right here. So then I can go ahead and draw this square within this black square right here. For the next one, we're going to do x plus 2 times sub. So now this is going to shift over not one of these, but 2 of these lengths. And so now the upper left-hand corner is going to be right here. So I can use this black square to draw this white square inside of it. And then we're going to do pretty much the same thing for each one of the other ones. The primary thing that's going to change is I need to specify where this upper left-hand corner is going to be located for each of those 8 black squares that's going to make up that larger black square. So we're going to have another corner right here, another corner about right here, we'll have another corner right here, another corner right here, and another corner right here. So we'll need to keep track of each one of those so we can actually draw out the white square that goes in the middle of those smaller black squares. And as I recursively call this, as we continuously step through it, on the next one we're going to have to keep track of this square. So again, that upper left-hand corner stays exactly the same as the original larger black square. We'll then have this black square here, so we'll need to get its upper left-hand corner, and then this one over here, we need to get that upper left-hand corner, and then so forth and so on for all of these. So you can kind of see the pattern as we go through this. As soon as I add an additional level of recursion, you can then see what I'm talking about with describing these slightly smaller 8 black squares surrounding each of these smaller 8 white squares. So we'll go ahead and take a look at that now. So let's go ahead and close this. Go ahead and run this again. And now we'll go ahead and apply 2 levels of recursion. So run that. And now we can see an additional 8 white squares surrounding each of these. I guess at this point we could call them the medium-sized 8 white squares. And then we have our smaller ones, and then we still have our larger one right here in the very middle of this. So this gives you a general idea about how the recursion is being applied and the overall pattern that we have to follow as we go through this. So now let's take a look at what happens when we continuously do this and we start adding more and more levels of recursion. So the last time that I did it, when we did it with 2, we had 64 of the those much smaller white squares. We also had 8 of the medium-sized white squares, and then we still had the one somewhat larger white square in the middle of that. So if we add all that together, that gives us 73 total instances that we had to call this draw gasket method. So now if I go ahead and apply this again, right now, well, now we've got 8 more white squares surrounding each one of these 8 white squares, which is surrounding each of these 8 white squares, which is surrounding this white square in the very center. So now I've got to do this yet another 64 times 8 times, plus all of the 64 times, the 8 times, and that 1 time in the middle. So now the number of calls that I have to make to draw a gasket has gotten much, much larger than it was before. So let's go ahead and try this again. Let's change this now, so our recursion level is 4. So now when I run it, now we can see 8 more very tiny squares surrounding each of these 8 squares, which are surrounding these 8 squares, which are surrounding these 8 squares, which is surrounding this square right in the middle of it. And you'll notice that for these squares that I've got right here, these are very tiny. These are actually just a single pixel in length and height. So they're just dots, little white dots showing up on our pane. And because of how small these are, this is why it is that I needed to use that slight rounding trick right here, where I set the dimensions to be 699 by 699, but then the value that I'm passing in is 700. This is the reason why I had to do that. Okay, so let's see what happens when we run this again. So we'll go ahead and clear this. Go ahead and run our Java carpet. And now let's make it a recursion level of 5. So if I do this, it takes a moment, and now it actually loads up. So you'll notice that there was a slight delay in the amount of time that it took for the program to load. You'll also notice that at this point now, because of how small they were at recursion level 4, when we go up to 5, they're so small that they can't even be drawn to the pane anymore, so you can't actually see anything. So at this point now, it would kind of be pointless to continuously run this in terms of trying to see anything different with our actual application. Nothing's going to change about it visually, but let's go ahead and take a look and see what happens when I add just one more level of recursion to this. So I'm going to go ahead and set this to 6. This will be the last time that I try to run this, and you'll notice almost immediately why this is going to be the last time I try to run this, because I've already been talking for a few seconds now and still nothing has happened. And now it finally loads. So at this point now you can see with a recursion level of 6, it starts to take several seconds for this to load. And the reason for that, as I've already been hinting at so far, the number of times that I have to call the draw gasket method has been kind of blowing up exponentially. So at this point now I have to call it so many times that it takes, in terms of computer time where you're trying to operate in nanoseconds, it took a couple seconds. So it takes a very, very long time for it to fully load this program now. Okay. So at this point, this is going to cover everything regarding this Sierpinski's carpet or Sierpinski's gasket. Took a look at the code for this program. We talked a little bit about exactly how this looks when we actually draw it out and why it is that these methods need to be the way that they are. And we also took a moment to look at the performance constraints when it comes to using recursion in this way, where we've got to make an exponentially large number of recursive calls in order to draw out this particular image. Okay, so this is going to wrap up everything for recursion. This will cover essentially all of our introduction to recursion as well as our various problems that we've looked through, wrapping up right here with this look at recursive graphics.